right. Thank you very much for the introduction here. So I'm going to start out actually today by making sure that you guys are paying attention by giving out some freebies. Wow, if I can actually reach with these things. Does anybody want to snort T-shirts? All right, raise your hands. Oh, she was first. Oh no, oh dear. This is why I'm a nerd and not a football player. So actually, I have more of both the shirts and the pigs, and I'm going to be giving them away at Hack in the Bar this evening at 7:30, which SourceFire is sponsoring. So make sure to come on through for that. So on to the talk itself, which I've titled "I Know Kung Fu: Analyzing Mobile Malware." And actually, the reason that I've got that title is because honestly, when I submitted this talk to Hack in the Box originally, I didn't know anything about mobile malware analysis. I just knew that I was going to have to start doing it soon for work because SourceFire has customers in the telecom industry who were interested in detection for all the mobile malware related threats out there. And well, if I put in for Hack in the Box, it would force me to get the research done if I got accepted, and they were kind enough to bring me out here to Kuala Lumpur today, and well, that meant that I got to cram all this stuff in my brain as fast as Neo in the Matrix learned Kung Fu. So a little bit about the SourceFire and the vulnerability research team for those who may not know us. I'm lucky enough to be one of the people who comes to security cons, and a lot of people seem to know who I am already, but just in case you don't. So SourceFire was founded in 2001. The vulnerability research team came along with the founding of the company. There are 25 team members these days. The core group is based out of Columbia, Maryland. For those who know the area, it's essentially halfway between Washington, D.C. and Baltimore, Maryland. And we've got additional folks in Seattle, Poland, Italy, and Germany. And the mission statement that the marketing people like to use is that we provide intelligence and protection to allow our customers to focus on their core business. And really what that means is that we're the guys that write the detection, the actual snort rules that are used to find threats in the field. We're the ones that do all the ClamAV signatures as well, and so we're kind of the public face of SourceFire out in the snort community. So moving along here, the question that I think a number of people may have when talking about mobile malware analysis is it a real threat or is it just a bunch of hype? I think that's an especially relevant question given the number of mobile malware talks that I see here at Hack in the Box. I mean, it's funny, I pulled up the schedule here and saw that the previous two talks were both Android malware analysis things, and I went, oh, holy crap, what am I going to do to contribute something, fresh here? But, clearly it's a big trending thing. I had an interview with some of the local press this morning, and all they wanted to talk about was mobile this and mobile that. And so, the question is it a real deal or is it a bunch of hype? So some statistics for you. ClamAV being the open source antivirus project, SourceFire acquired back in 2007, and so we have access to their full database of malware, and they trade samples with other vendors throughout the world. And so, it's a reasonable representation of the amount of malware that is running around the field. We have 962 Android-specific samples in the ClamAV database, 338 Symbian OS samples, and really pretty much nothing for iPhones, which was an interesting little piece of information. But the thing of it is that compares to about 40,000 desktop pieces of malware that come in every single day. So, you look at the numbers there, and obviously it's a tiny drop in the bucket compared to, traditional malware out there. And so, from that perspective, it seems like, well, maybe it is just a bunch of hype. Maybe it's not really a threat. But the interesting thing that I noticed as I was, compiling the numbers for this talk is that the rate of growth in the samples that we're getting into the ClamAV database is actually fairly high, and it is continuing to accelerate. Of the 962 samples that are in that database, about 200 of them came in just within the last month. So that kind of gives you an idea of the trajectory of where things are going. And the reality, too, of it is that these things aren't just showing up in research databases. These aren't just off in labs. This stuff is actually out in the wild. In doing the research for this talk, I went out and did some study on where these things actually appeared in the field. And there was a Zeus variant that was released on Android in July and spotted in the wild, which is kind of a scary thing when you consider how much damage the Zeus botnet has done on regular computers. Now it's extending its reach out to Android phones. There are a number of instant messaging clients that are designed for the Chinese market. IM is extremely popular in China, more so I think than North America. And there were a number of Trojan, versions of IM clients available in different Chinese app markets that have definitely, been hitting people out in the field. And in addition to that, we saw actually just a little over a week ago, we saw there was in Russia an SMS Trojan that was being distributed by QR codes on different websites. And, that one was interesting. We've got actually 50 different variants of it that we've collected in the ClamAV database. And I thought it was particularly interesting because it sends text messages off to premium numbers and thus actually hits you directly in the wallet. And, that one led to just a side thought here that is not the focus of my talk today, but is something that I'm actually pairing with Bobek over in the Lockpick Village to do some research that we're looking to present at ShmooCon this year in Washington, D.C. on the question of, will people actually scan random QR codes in the wild? And so, when we found out that these things were being spread by QR codes in Russia, could this happen in the States? And so I actually ran a small experiment in Washington, D.C. to find out if people would. And you see a picture there. That is a newsstand on the corner of 22nd and 8th Streets Northwest in Washington, D.C. that I printed up that QR code with a little message, hey, are you tired of excessive bank fees? Scan here for more info. And as you can see, I didn't put a hell of a lot of effort into being sneaky about it. I mean, if you look at that, that's about as sketchy as it gets. But the funny thing was, people actually did scan these things. We sent folks off to a URL on labs.snort.org that was tracking the number of hits that came in, the user agent strings, the time of day, all that sort of stuff. And what we found was there was actually a slow, steady trickle of hits on that thing. We actually had, in about a week's time, we got 50 total scans. And it was everything from, BlackBerry to iPhone to Android, with a mix of, obviously you see English users, but also we saw Korean character sets on the user agent strings. We saw Chinese, character setup. So there were a variety of different people actually, seeing these things just on the side of a mailbox or on a newsstand or whatever and scanning them, which, is interesting because of all the possibilities of what you can do once you've sent somebody off to a URL of your choosing. So, that, like I said, that was a quick experiment that essentially validated the work that's necessary to be done for more in-depth research we're going to be presenting probably in January here. So today's talk, kind of like the other ones that came before me, are focused on Android specifically. And, sort of the reasons that it makes sense to look at Android specifically when you're talking about mobile malware. First of all, it's an open, well-documented platform, unlike a platform that starts with an I and ends with a phone. And, what that means is that, there's lots of good tools available for doing analysis on Android malware. Every time I ran into a problem when I was starting to do this research, I put in a quick search on Google, and 2 seconds later, I had an active project on Google Code or some other place that solved the problem for me. So I had no difficulty getting tools to do the work, and that, that makes your job easier when you're doing analysis, obviously. The other reality of it is that same openness makes Android easy for attackers to use. At the end of the day, hey, it's a Linux kernel. I know how to hack this. There's plenty of people out there that know all about Linux internals, that know Java, which all the applications are written in. It's really not a huge learning curve for attackers to pick up, to understand the environment, to create an app that does malicious things. And so it makes it an easier target at the end of the day. And of course, the other reality is that Android has about 50% market share of the smartphone market, depending upon which study you look at which time. But even if it was only 30 or 40%, obviously that's big. It's relevant. It's something that matters in the field. So the whole process of this, I said, all right, if I'm starting from scratch, the question is, all right, APK is Android package files, and so the question is, I've got an APK. Now what? What is this? And it turns out that it's actually just a zip file with a different extension. You can actually just run good old unzip on, a command prompt, and it will dump out all the files for you. No password, no encryption scheme, none of that. Just straight up zip file. And when you first open this thing, you get a whole bunch of, things you don't care about. There's a meta information directory that has crypto certificates, so that these things are digitally signed and you can do identity verification. There's a manifest file that is full of SHA-1 hashes that get checked to ensure package integrity so that things were downloaded properly and not corrupted in transit. There's an asset directory that has, essentially it is Etsy for the application so that it can store all of its config settings and persistent variables and things like that. There's a manifest directory that has an XML file that is full of things that for a malware analyst you really don't care a lot. There's also a res directory that is resources that it's mostly the images that make up the GUI and all the pretty stuff that goes along with the application. So, all right, so there's a bunch of crap we don't care about, but here's the first thing we care about. The manifest, not just, not the manifest directory, but there is an Android manifest.xml file. And I saw that, and I went, oh, sweet, XML. That's easy. VI, oh, damn it, Google, that's not XML. It's actually a DBase4 file that contains XML and some other stuff. And when I saw, okay, DBase4, I'm old school, I remember that from the 80s, yeah, whatever. We go, okay, there's a DBase4 tool on Linux, all right, apt-get, whatever. But no, it's not actually DBase4 precisely either, because the standard tools to read those kinds of databases on Linux, they're kind enough to just crash on you when you try to open up that Android manifest.xml file. And, thankfully, hey, this is, back to my earlier point, did some more Googling once I figured out that it wasn't a standard DBase4 file and found out that there's a tool that will actually specifically dump the Android manifest.xml into standard XML format. And it's available at the URL that I've highlighted there that, Dylan was saying earlier that the slides for this are going to be available online as soon as the talk is done. So anyone who wants to get that URL, sure, you can copy it down now, but you can also get it later online. And the cool thing about this tool is that it's completely cross-platform. It's available in distributions for Linux, Windows, and Mac. So it doesn't matter what platform you like to do your analysis on, they've got a tool available for that. So the other thing that is in there once you get to the actual XML file and through all the Google-specific junk that's on top of it, is there are permissions declared in that XML file. And essentially, all Android apps have to declare what permissions they wish to have. And that is, anybody who's got a Droid phone and has installed an app knows that when you're updating or installing an app, it pops up and says, this application wants to access the internet, have access to phone state, have access to battery life, so it, all those sorts of things. And that, the permissions that are listed in the XML file map directly to what's displayed on screen when you actually do the installation. So you can see right there what an application wants to have permission to do. And essentially, this is Google's attempt to do the right thing, in quotes. The idea is users will have full control over what an app might be able to do. They'll be able to see right on screen that, this app wants to have fine location information on me, which means it can track me wherever I go, and I'm not so sure I like that, so maybe I won't install it. There's sort of a clear segregation of powers in that, you have a good Linux-style, permissions set up, and it's not just a muddy case of any app can do anything. The idea, I think, from Google was that developers would be constrained to exactly the things that they asked for up front, and it wouldn't be a case of any app can do anything. But the reality, of course, is that while that all sounds good in the lab, it's messier than that in the field. Some of the permissions that are out there just look scary right off the top. I'm starting to dig through there, and I saw the call phone permission. I said, call phone. Okay, that sounds interesting. Let me pull up the Google documentation on the API. What does that mean? And I quote, allows an application to initiate a phone call without going through the dialer user interface for the user to confirm that the call is being placed. Holy shit. So my phone can just call somebody without me, without asking me? What kind of crap is that? Google, what are you doing even allowing an application to have a permission like that? And I said, okay, of 877 apps that I had when I was doing my analysis that I knew were malicious, 98 apps have that specific permission. And so clearly, I'm focusing research on this. What is this all about? How does it operate? And then the very afternoon that happened, my ING Direct banking application, my totally legit bank online setup, wanted to do an update, and I said, I should pay attention to the permissions on this. I went, allow application to make phone calls without user interaction. Holy shit, did I just discover a huge flaw in, a major bank app? Am I going to be able to make, international news on how ridiculous the ING bank app is? Well, as it turns out, no. Of course, you would have heard about it by now if I had, made the international news. But what happened in that particular case is that the program itself takes care of prompting the user for whether or not they want to make a call on its own. And actually, that screen is good enough that you can probably read, but this is the Java source of the piece that leads up to making a phone call in the ING Direct app. And you can see it says message box, declares a variable, and it has a string for calling, and it prompts you with a, do you want yes or no to make a call? And I pulled it up in reality, and it was easy enough to find. It's in the little contact us link, and it says, do you want to make a call? And if so, it just makes the call without you having to press the green dial button. So, not that scary at the end of the day. And it turns out, even more interesting, part of the thought process going into this was that permissions would be a really valuable sort of first layer of data on whether or not something is malicious. And that it's muddier than that. Most of the applications that have call phone as a permission listed don't actually use that permission. It's, not a sure thing that if it asks for permission to do something, it actually does something with it. And of course, I had a different app that asked for all of the permissions that are listed there. Access network state, talk to the camera, expand the status bar, vibrate, send SMS, battery, just all sorts of things. And when I looked at the code, it actually used 2 of those permissions. And so while it's a screen in the sense that without having a given permission declared, you can't actually perform the function necessary, unless you root the entire phone, which essentially none of these apps do. Just because a given red flag permission is in there doesn't mean that you're going to see that functionality used by the app in the wild. I said, well, is there any other value in this process of analyzing permissions? And so I compared the number of permissions that were requested in about 1,400 legitimate apps versus 760 malicious apps. Of the 800 odd that I had analyzed, there's a number that don't even ask for any permissions at all. They're essentially broken. And I did note that, the median number of permissions requested by malicious apps was 7, and legitimate apps asked for 3. And I thought, well, maybe that's an indicator that you can look at just with this XML analysis. But the reality of it is that there was, one malicious app that asked for 39 permissions and a legitimate app that asked for 34. And the funny thing was, as I sifted through and looked at the legitimate apps that asked for the most permissions, the one that asked for the most was the Netkin Mobile AV suite, which is this fake AV? Is this real? No, it actually turns out it's a perfectly legitimate, well-reviewed mobile antivirus tool. But there were actually a number of different emerging mobile antivirus platforms, and they were the ones that occupied the top end of the permission use spectrum for legitimate applications out there. And essentially the statistical distribution was just scattered all over the place. There was not good clumping, and so the number of permissions that you request isn't just a simple red flag that you can end your analysis there. It's a starting point, but it's not definitive in any way. And of course, it goes back to the issue of how I say Google was trying to do the right thing with permissions here, but it's a messy situation because the reality of it is, sure, it declares on your phone all the things that an app wants to do, but who the hell looks at that when they install their app? Nobody except maybe security researchers. And even in my case, I haven't paid attention to them until I started doing mobile malware analysis, and I'm a paranoid hacker type. So it's just, at the end of the day, it's like, end user license agreements. Yeah, click through, sure, whatever, I agree, I sell my soul to Google, Of course, they're not completely without value. There is the send SMS permission is the one that I thought was the scariest out there. There was one app that I thought was especially hilarious. It's called Porno Player, and the only permission it asks for is send SMS. So essentially, it tricks horny guys and, sweet, I'm going to get all this hot, video chick-on-chick action, and then, no, you just get a huge phone bill because they're sending off toll messages that are going to show up, and, now your wife's going to go, hey, what do you have all these premium numbers on here? Oh, sorry, honey, I was just trying to get Porno Player running. And the thing about that particular call is it happens, you can send a text message completely in the background. There's no box that pops up that shows that this has happened. With the call phone permission, you at least get the dialer, you don't get the dialer prompt, but you get the little phone display showing that a call is in progress. With send SMS, the text message just happens in the background. And the reality of that is, if you were to try a scam where you dial one of those numbers in the Caribbean that charges $4.99 a minute or whatever, a user can notice that the phone call screen is up and terminate it, but a text message, it just charges instantaneously. So you can silently be sitting around in the background racking up hundreds or even thousands of dollars of charges on any given phone, and the user will have no idea that it's going on. One quick sort of side note on the issue of Android emulators and text messaging, and I'll talk more about the emulator process later on here. But one of the big drawbacks of using an emulator to study text messaging is that it's not actually rigged up to a phone network. I can't turn my emulator onto my Verizon or AT&T or whatever the Malaysian cell phone service happens to be. And the emulator itself can in fact send text messages, but just to another emulator. And essentially the Google documentation shows that it's designed in such a way so that you specify the port number that the second emulator is listening on as the phone number that you're sending a text to. So, your first emulator always shows up on port 5554, the second one's always 5556, and so all the documentation shows that that's how it works. In theory, you could capture text messages by listening to that port with TCP dump or Wireshark or whatever, but I was not able to get that to function in my research, and maybe that's just what I get for being so late to the game on this. So moving along past permissions, the other really useful piece that you get out of unzipping an APK file is the actual code. which is in a file called classes.dex. So everybody here has probably heard, hey, Android is Java powered. So the actual code itself, that should be Java bytecode, right? No, not so much. It turns out that it's actually a Dalvik executable file, which is a format that's specifically designed for register-based virtual machines that Android devices are a good example of. And the whole point of it is it's specifically set up for speed on resource-constrained systems. So not only mobile phones, but embedded devices, things that don't have, 8-core, 2.4 gigahertz and, 16 gigs of RAM, but are, more like 512 megahertz and, a couple of gigs of RAM. And what essentially happens when you are compiling an Android application is that the Java bytecode is translated into Dalvik bytecode before installation. So, I said, all right, well, how do I actually get at the code? Because it's hard to do, analysis of code without actually being able to see it in anything but a binary format. An APK tool that I mentioned earlier that processes the XML file into a human readable format actually includes a DEX file disassembler. And you can see here, this is an example of some of the disassembly output that it shows. And I don't expect you to sit down and read all that, because the reality of it is that I didn't. So it turns out that if you think about it, DEX is derived from Java. So can you convert DEX back into Java? Makes sense. Why wouldn't you? And the reality of it is like I was saying, that disassembled language that you get back out from APK tool, not exactly easy to read, even if you know like x86 assembly. I know enough x86 assembly to be dangerous. I'm not a brilliant reverse engineer, but I can look at a pop ret or something like that and identify what's going on. And even for me, looking at this disassembled output from APK tool is hard. And it turns out that there is, in fact, a good tool to convert DEX back to Java. The URL is up there again for anybody who might be interested in pulling this down later. And again, it's a nice, simple command line tool. It's cross-platform. It's available whatever environment you're using. And once you've got a jar file, you can just use any of a variety of Java decompiler tools out there. I found there's a particularly cool free Java decompiler GUI that runs just on Windows, but that's fine because that's where most of my tools are anyway. And the last two lines that you see there are the actual Java source that was that entire page of DEX disassembly the last time around. So obviously it's a lot easier to read Java source than it is a DEX disassembly. So with that background, now that we know what is in an APK package, it's time to do a real-world sample and lead you through an actual analysis of something out there in the field. And the cool thing is when I first started outlining this, I'm like, I wonder which samples I'm going to use. And then I saw this Russian QR code SMS thing, and I went, oh, this is perfect. It's in the news. It's relevant. It costs people money. This is something I need to do as a sample. And so once I had it all decompiled back into Java source, immediately could see that it was heavily obfuscated. These are the names of the different classes and subclasses within the Java source, and that's not even that it's Russian and so it looks funny. That's just straight up random character sets. I mean, A, P, 8, E, O, V, K, V, no, that's not valid in any language. And the code itself is really no better. It looks actually, not only is it intentionally designed to be obfuscated and difficult to read, but it was actually probably built by a kit of some kind. Because of all those 50 different variants that we had, there were a lot of commonalities in the way that things were obfuscated. Not that it was the exact same strings, but similar format strings, similar number of subclass files, things along those lines. And if you look at the variable names themselves here, you have a function call like ABFNENBW, and it's designed to make a human that's looking at it have a hard time figuring out what's going on. Because I don't know about you, but if I'm reading source code, it's a lot harder to think logically about what int A6SHLB is than int return code or some other meaningful name. And the thing of it is it looks actually a lot like a lot of the malicious JavaScript that you see in the wild on pages that are using JavaScript to do a heap spray and then drop shellcode on a box through some sort of Internet Explorer vulnerability or something along those lines. So I said, well, we know it's obfuscated, but we kind of expected that because it's malware. So let's cut to the chase of this here. We know that it's an SMS Trojan, and it only has 8 subclasses, 3 of which have fewer than 10 instructions. So there's not actually that much code to go through. It's not like you're trying to debug Microsoft Word, which is millions and millions of lines of code. This one totaled out around maybe 1,000 lines of code. And because we had, the pre-knowledge that this thing was an SMS Trojan, it was real easy to see in there, oh, look, send text message. There's the function call. All right, this is the relevant piece. So the question is, let's, pretend for a moment that we don't know that this is a Trojan and we're just analyzing a random sample from the wild. The question would be, once you see the send text message call, is it malicious? So the declared format of the call is you put in the destination, the source, and these are both phone numbers, the text you want to send, and then some intents, which are essentially action triggers within the Android environment so that other applications or your application itself can pick up and know that a text has been sent or is being sent and kick off useful code based upon that. So our malicious app essentially sets, string for the destination, null for the source, which at first seems suspicious, another string for the text, and a couple of pending intents. All right, that, for all intents and purposes, the call itself looks perfectly legitimate. And just to compare to a legit app, SMS Control Center, my initial suspicion that not setting the source address for the text message was a red flag in and of itself. No, this thing used null for that as well, and so even that is not all that useful. So the question came down to tracing back through the code to figure out where the number and the text, the piece that it was sending within the SMS message came from. And so I said, okay, I can see that it's, this variable is declared here, and all right, so this function is called and passes it along, and this and that, and it turned into a complete wild goose chase. There was one piece where it made a function call to this AP8E thing, and I go and I look, and that class, that function, is completely empty. Nothing there at all. Designed just to throw an analyst off as they're digging through and figuring out what's going on. The actual pieces that, do a get string are on big random numbers, and those are defined elsewhere in the file, and it's not straightforward at all. And the end result of that analysis essentially is that it's really clear without even going all the way back through that entire 1,000 lines of source to exactly where those strings are defined that the app's hiding something. A legit application, this SMS client thing, gets the phone number that it's going to send an SMS to with get phone number, parameter string. Real simple, real obvious, something that, a programmer who is concerned about his boss coming through and doing a code review would do so that it's real obvious what's going on. In this particular case, if you trace the whole way through and you happen to know about the Russian phone number system, you can see that, this thing is in fact sending numbers to a premium service, but frankly, it's a painful process to go through and dig that all the way out. So, so that's a little bit of static analysis that we've done here. But of course, whenever you're doing malware analysis, you have two options essentially. You can either do static analysis, which is just reading the code in whatever format you can get to it, as compared to dynamic analysis, which is running an application and observing its behavior in the wild. And some of the sort of pros and cons of the two for anybody who doesn't really do malware analysis and is just trying to figure all this out. The pros of static analysis are, it leads to, you can do good automated code analysis. You can stick tools on essentially looking for patterns in the source and things like that. You're guaranteed not to have any oops moments where you accidentally let malicious data go out to the internet that you didn't want to go out, and find out that, when I first set up the malware research lab at SourceFire, our outbound facing internet pipe got blacklisted by a whole bunch of different services because all my malware was sending spam and doing horrible things on the internet. And the next thing we knew, even Google was putting up captchas for our users to search because it looked like we were just full of evil. And so static analysis guarantees that you can't screw something up because you're not actually running malicious code. And of course, you also get full visibility into all the possible things that an application can do. Because sometimes malware is complex, there's a bunch of different code paths, and just by running it, you might not click on the right thing, you might not have the right version of, be it Windows or Android or whatever, and so you don't necessarily have the full picture of what's going on. But the cons of static analysis are that it is a very slow, difficult, time-consuming process, and you've got to be, frankly, good to do good static analysis. I like to think I'm all right at it, but even I know that I could certainly be better, and I'm up here talking about it at Hack in the Box. And of course, it's also vulnerable, which I put in quotes, because it's not a true vulnerability, but as a human, you're vulnerable to obfuscation methods that make it more aggravating to go through the code. So, the question is, all right, what about dynamic analysis on Android? And the first thought that you might have is, well, but shit, I can't just infect my real phone. That's not cool. But the good news, of course, is that you don't have to. You can just install the Android SDK. And it, of course, is multi-platform support. No surprise that Google is open, to different platforms. It's well documented. It actually allows for snapshotting your virtual machines, which is really useful for malware analysis because you can have the same virtual machine and infect it with different pieces of malware, or you can essentially pause your state as you're doing your analysis and come back later. You can pick and choose different Android operating system versions, so all the way from like 1.6 out to the development 3 point whatever. Java is the only prerequisite you need to get this thing running, and Java is free, and that's not a big deal. It is, of course, free, both in the sense of free as in beer and free as in speech. And, of course, it also integrates well with the free Eclipse debugger. So it's got a lot of good things going for it. So the first question that you have once you get that set up, or at least that I had, was, so how do I get apps onto my virtual droid? And I said, okay, well, let me just go to the market. Oh, no, the market app doesn't come pre-installed on virtual droids. So that, it's kind of aggravating, but if you want to get an app from the market, what you can do is install it on a real device, use the Astro File Manager app's backup feature, and poof, it saves off an APK file that you can then get onto your virtual emulator. Any other app, if it's on the web, just download an APK file. If it's not on the web, there's an ADB push command that comes with the SDK package that you can use to just send the file off across the Android debug bridge to the phone and then install from there. Or you can also just use ADB install to directly just launch the install process on the phone. So with that done, with that sort of background set up, I'm going to talk about another sample here called Droid Kung Fu, which, hey, even ties into the title of my paper. Sweet. It's fairly well-known Chinese malware, and fairly because, well, if you're not in mobile malware analysis, you probably haven't heard of it. But anybody who's kind of in the field has heard of this thing. There are publicly available samples at the URL that I've listed there. I've got to take a moment to give props to the guys running Contagio Dump because they have lots of real samples and good analysis of in-the-wild malware. And it requires Android platform 2.2 or lower. Essentially, it exploits some known vulnerabilities that were patched by 2.3. The thing to note there is that it's not a bad idea generally if you're trying to analyze in the wild malware to run version 2.2 or lower, because about 85% of the phones in the wild today are on that version or lower. So you want to kind of get what is actually out there in the wild in your lab. The other cool thing about this is that that particular app is known to generate network traffic. And since I'm an IDS guy, hey, I like network traffic. So, here is what it looks like during the install process. Yes, okay, it's in Chinese, but hey, shocker, it's a Chinese app. And it asks, do you want to install this application? And looking at it, it says it wants access to storage on your SD card. Okay, no big deal. Network communication, well, it's a instant messaging app, so of course it wants network comms. It wants to do phone calls, which, all right, we already said people don't pay attention. And it wants access to system tools, which is a little bit funny, but, well, whatever, fuck it, I just want my, my SMS tool. So the runtime behavior of this thing, the very first thing it does is it pops up a little window. It says, replace application. The application you are installing will replace another application. All previous user data will be saved. That's a little funny considering this is a fresh emulator install, but I'm just going to pretend that I'm in the wild and click on through, and that's fine. And then, poof, it pops up a window in Chinese, which, all right, that's cool if you speak Chinese, but if you're an American like me who doesn't speak a word of Mandarin or Cantonese or anything else like that, not particularly helpful. The good news in this particular case is I was in Singapore earlier this week at our corporate offices there, and oh yay, we've got people who speak Chinese there. And so they told me that what that says is the little top piece says, hint, and it says, you are about to connect to the internet. And the big button says, okay. So, okay, you click that, and it just goes away. Application closes. And so, that seems a little suspicious, but maybe if I had this thing in the wild, I would think, it's just broken, it's a crappy app, I'll get around to uninstalling it later. But of course, I'm doing malware analysis, I've got other interests, so let me see what this thing is doing. So, having dug through the code on this thing, which thankfully, given that this was tens of thousands of lines of code, I was lucky in that there were public analyses of this tool, so I kind of had an idea of where to look. It has a statically configured HTTP string that you can see in bold there. It goes to search.gongfu-android.com on port 8511 to search sayhi.php. Like I said, in this particular case, I was lucky in that I had pointers as to what was going on and where to look. But if you were dealing with something just completely out of nowhere in the wild, you have no idea what's going on, not a bad idea to look for the string http:// inside of an app to see what websites it might be talking to. From there the question is, all right, so this thing, we know it generates network traffic. How exactly do you capture that traffic on Android virtual devices? And it turns out that luckily this one, it's nothing special to it. You can just do it directly on the machine that you've got the emulator installed on using either Wireshark or TCP dump or whatever other sniffer tool that you want to use. The major drawback is filtering that traffic. With VMware, virtual devices get their own IP address if you set up bridge networking and it'll do DHCP and whatever, or you at the very least have a distinct MAC address for the virtual adapter, and you can use that to filter your capture when you're doing a packet dump. The problem is that the Android emulator is not exactly like VMware. It's just another app running on your system, which means that there's no distinct IP address, there's no distinct MAC address, there's really nothing that you can use to filter out the network traffic that's coming from your virtual droid versus from your actual underlying operating system. So, pro tip, make sure to close noisy programs before capture. The first time I was doing capture and I didn't realize that this was going to be the case, I had Google open, or Google Chrome open with Facebook tab and a Google Finance tab and all these JSON things that are pushing data here and there, and my packet capture was just full of junk the first time around. The one bonus, of course, is that unlike VMware, you don't have to fix up broken checksums when you capture from the machine sending the traffic. One of the things that irritates me as an IDS analyst is that if you capture a packet capture on a machine that has a VM on it, VMware skips the process of calculating TCP checksums and just leaves it up to the network card, which means that if you're capturing before it actually hits the network card to go out to the internet, your TCP checksums are broken, and so Snort won't recognize the file right, and it's just aggravating. But Google is kind enough to calculate those checksums for you, so that saves a step in the process. And, you know, in this particular case, hey, sweet, it works just like we wanted. As soon as I got this thing installed, before I was even through these Chinese language pop-ups that I had no idea what they were, packets began to flow rather immediately. And you can see here, this is, you know, I didn't do the Wireshark screen capture because it would have been really hard to read. I've just duplicated the HTTP headers here. And you'll notice that the user agent string says Android 2.2, SDK build, blah, blah, blah. So it's real obvious that this isn't my Facebook traffic node. This is actually coming off the Android emulator and is useful data. And of course, immediately I note that this thing, the host that it's connecting to is port 7001, which is, again, not standard HTTP. It's not the same port as that earlier URL we saw, but even it is suspicious. And so that's an immediate red flag to look at. And essentially, I said, well, I really want to confirm that it still does what we saw in the source code. And, you know, this is one of the pros of doing dynamic analysis, is you can easily confirm that what you think is going on in your static analysis is right. And as I said there, the URL that this thing went and immediately started talking to was distinct from the URL that I had highlighted earlier, which is known from the analyses that are out there publicly to be its command and control check-in. So, all right, fine. I'll just I'll go get some coffee and let it run. No big deal. I'm sure it'll talk to it later. But it didn't actually go there. And I started, you know, I opened the app back up hoping that I would get something out of it. But no, every time it just pops something up in Chinese, and when I click the only OK button, it goes away. So it's not like I can force it to do something different because it's not responsive when you actually run the program. And sure, I could sit down and analyze the code and see what the prerequisites are to trigger that particular request, but that is a long, difficult process. And to be honest, I'm lazy. I like to cheat wherever I can. And anybody who's doing malware analysis, I think, should adopt that philosophy, because there's so much work to do that if you can get a successful shortcut or workaround or whatever and make it work, it's going to make your life way easier. So I said, what if I just reboot the phone? Just treat it like it's Windows. Bingo! It did exactly what I wanted. It posted off to search/sayhi.php. It's, you know, on port 8511 on that host that it said earlier. It's got a user agent string for HTTP client unavailable, which is proof that it's not even using the built-in Android operating system stuff to send that. It's got its own custom user agent string. All right, there we go. And then we notice later on, after it sent that initial check-in, it's sending off data about your phone. So you can see in bold there, OS type is 2.2. So that's the version of the operating system we're running. Mobile equals a 555 number, which is standard fake phone number that you'll see in the United States. Mobile model, it's the generic SDK, but of course if this was on a real phone, it might say Motorola Droid or some other thing like that. And what I thought was particularly funny is in the HTTP response that came back from the server, it has standard HTTP headers. All right, it's running on Apache, CentOS, no big deal. But the only data that it sends back besides the header is fail. Okay, that's odd. You know, don't know what that's all about. But hey, from a network detection standpoint, I don't know that I particularly care whether or not it succeeded or failed, because you can easily still identify this app as being on a given mobile phone simply by the fact that it's called on out. And you know, it's possible that it sends back fail so that an analyst who's looking at this traffic would think that the CNC network was broken and not pursue it further. You know, malware authors do strange things. So, you know, the good news in this case from a detection standpoint, and of course being the SourceFire guy who does IDS signatures, I'm always thinking, how can I detect something like this running in the wild? In this particular case, the call home routine is hard-coded into the binary as a straight-up string. It's never going to change. It's not randomized. It's always on the same port. It's always the same URL, so it makes for a really easy snort signature. And essentially, for anybody who doesn't know snort signatures, what that thing says is generate an alert when you see a TCP packet coming from your home network, which you're protecting on any port, out to the internet, the outside world, on port 8511, with the message botnet CNC for the category. It's a Droid Kung Fu check-in. It's a TCP session that is established. It's in the direction of the server. It looks for the post string within the first 22 bytes of the file, and then there's some other metadata about what's going on there. And the SID there is the official snort ID that tags that rule in the SourceFire sponsored rules. This thing is actually available in the wild to anybody who downloads the snort rules off of snort.org. So, the funny thing is all right, so I've done that app, but the question is, do most of these applications just send text messages that you really can't detect with an IDS because they're on a whole different part of the network? Or do they actually generate network behavior so that I can go back to the folks at Verizon Wireless who are concerned about seeing mobile malware and say, no, I can actually do something for you from a snort rules perspective. And I picked another just random app out of my list and did a packet capture, and you can see, well, actually, yeah, it actually does send nefarious network traffic. This is a post off to aap.do. Okay, that doesn't make any sense. It's got that user agent unavailable Java that looked just like the Droid Kung Fu thing, so maybe there's further evidence that there are kits out there that are generating this malware. And if you look in the post data, you can see it says model, SDK build, the brand is generic. It's sending off data about what kind of phone it's on, which is just like your standard sort of check-in for regular desktop PC malware, because if I'm running a botnet, the first thing I want to know on any given infection is, all right, what have I got? What kind of resources do I have on this device that I've compromised so that I can then figure out what it's going to be useful for? So, even samples that were primarily focused on SMS fraud will sometimes exhibit obviously bad network behavior. Jim Russia, which is the name of that QR SMS Trojan that I talked about earlier, one of the variants that I had immediately downloads the file gym.apk from androidgym.ru the second you install it. Okay, well, no app should instantly be pulling down another app the second you install it. Clearly, it's a downloader that wants to put as much malware on your system as possible. As soon as that is done and it's silently installed in the background with no user prompt at all, it's followed by several beacons out to different ad servers. And it's not that it's legitimately getting an ad to display to the user, because there's no indication at all on the phone that, hey, you're getting an ad to support this program. So most likely what's going on here is some kind of click fraud, which is standard operating procedure for a lot of the Russian criminal syndicates that are generating malware. Those guys, the Chinese may be focused on stealing American military secrets. The Russians just want to make money. And it doesn't matter if you're doing it through, SMSs to premium text services, or click fraud, or extortion, or whatever way you want to do it. Hey, as long as they make money, they don't care. And the reality of it is that phones these days have plenty of bandwidth on them. You've got 3G networks. You're starting to see 4G roll out in the States. There's all these phones, of course, are on Wi-Fi networks as well. I know that when I'm in the office, my phone syncs up to the local wireless, so it's got gigabits of bandwidth at a time. And so realistically, given that background, the chances are really high that phones are going to be used as sort of standard bots, just like desktop bots, are today. Because essentially, if you think about it, cell phones are just laptops that we carry around in a tiny form factor in our pocket all the time. So why not use the dual 1 gigahertz cores on the new Droid that's available from Motorola to do your spam generation or DDoS activity or whatever else, just like you would some cranky old PC running Windows 95 that has 10 viruses on it already. So that basically wraps it up here. That's my analysis. This is contact information on how to get in touch. We've got the VRT blog we publish technical articles on. You can also find us on Twitter. And I would encourage anybody who's in this room who's interested in this sort of stuff to not only pay attention to what we're doing on the public push forums, but to feel free to reach out and contact me directly if you have questions, you've got ideas for analysis, that sort of thing. Not only on Android specific stuff, but frankly, I said I've got this giant malware zoo. It's got terabytes worth of network traffic. If you've got ideas you want to play with, boy, if I got the data to do it with. So thank you very much, and I'll open up to questions. Anybody? All right. I will also obviously be around afterwards, both here in the hallways and at Hack in the Bar tonight, if you feel like you don't want to ask a question in front of everybody and be concerned that it's something silly. So with that, I guess I'll turn it back over here.